relatively quickly so we can ask questions. Okay, motivation. I mean, look, I guess just to summarize all the threat stuff from yesterday, at a very high level, cryptocurrency and Bitcoin is unique because you authorize your own spending. It is a bearer asset, right? Banks do your transaction for you in the traditional financial system. So if we have a quantum computer out there, someone else can authorize spending for you, right? So it calls into question this entire idea of who owns a Bitcoin if someone else can spend my Bitcoin, right? So the other way to term this, what I'm describing, is self-sovereignty, right? So this is the term that I like the most. Cryptocurrency generally, and Bitcoin obviously in a specific case, is defined by self-sovereignty, right? Obviously there's decentralization and a bunch of other things, but self-sovereignty is fundamentally the principle that's being violated here, right? And I think the first order of business is to tackle that problem. So a lot of people, I think at this talk, or in the past several talks, we've talked a lot about protocol stuff and different things we should do, BIPs, etc. That is great. But I think I just put this up here. Sorry, this is like very primitive slide making technique here, but hopefully you can get the point. There's going to be a lot of effort beyond just fixing the protocol. I think it can be very easy to fixate on the protocol and what needs to fix and which signature schemes, but we have to remember that beyond the protocol, there's an entire stack and a galaxy of applications that all have to accommodate whatever changes are made at the low level, and also ultimately have to migrate to a new scheme, right? So I think an analogy that some people have talked about previously is Taproot, right? Taproot, I think personally, is a really great addition to Bitcoin. Obviously, it sounds like very likely it will have to change, but just taking that upgrade for what it is, most Bitcoin users do not use it, right? And that is very, very different from what will have to happen here. As we heard from Jameson and the debate around what to do with Satoshi's coins, not adopting an upgrade like this is a fundamental security vulnerability that impacts not only the individual's assets, but everyone around them. So at Project 11, we're kind of more focused on this level, right? Obviously, there's a lot of stuff that's going to happen to the protocol, and we're, of course, not independent of the protocol in any way, shape, or form. But Yellow Pages is really kind of focused on building wallet infrastructure is the best way to think of it for the ultimate migration to a post-quantum scheme. And when I go through, like I said, this is all live, so when I go through, you'll kind of see a flow that you're going to recognize because you're like, oh, this kind of looks like a wallet. And it is kind of what it is. Okay, so with that, let's go through a walkthrough of the product. Okay, fundamentally, the idea here is we have a key, your existing ECDSA key that authorizes spending of your Bitcoin UTXO, and that key can obviously is vulnerable from a quantum attacker. If a quantum computer shows up right now, there is no cryptographic way to prove ownership over anything, right? Because again, a quantum computer can recover a private key in a totally non-attributional way, and so therefore a digital signature using ECDSA means nothing, right? So what we need to do, going back to the kind of the problem, self-sovereignty has been violated, so that's your ability to prove that you own an asset. We need to enable individuals to recover their self-sovereignty. And so this is what we do here. So basically, Yellow Pages is a way to generate a new post-quantum key pair. We actually, technically under the hood, as you'll see in a minute, we generate two post-quantum schemes, because as you guys probably recall from yesterday, there's really two leading candidates, MLDSA and SLHDSA, and we can talk more about that in a minute. But you generate effectively two keys from a single seed phrase. You sign a message with those post-quantum keys, and then you bind that to your ECDSA signature. Now, there's a little bit of extra engineering that has to go into proving that's a valid signature without doxing yourself and your public key, and we'll talk about that. But fundamentally, at a high level, this is the sketch of Yellow Pages, right? And so this is more or less what I talked about right here. I think one thing to note, and again, we'll get into this in a little bit more detail a bit later, this is not just post-quantum at the level of the Bitcoin protocol, or like at the level of signatures, right? So as I think one of the presentations mentioned yesterday, there's a whole bunch of implications to quantum computing, or like for a quantum adversary across the stack, right? And so in our case, you're using, like I mentioned a second ago, there's some extra engineering that has to go into not revealing your public key. We use to do that a trusted execution environment, which is on a server that is remote to the client. So we need to ensure that client-server connection is secure, right? So we use ML-KEM, which is the lattice-based key encapsulation mechanism to basically ensure there's a secure connection between the enclave on the server and the client side, right? And so this is really, I think, to my knowledge, the first deployed infrastructure for wallets that uses hybrid post-quantum cryptography. Okay, cool. So maybe let's just get into the flow here, and then we'll go dive into details, and we'll take questions. Okay, so like I said, like I previewed, what does this look like? So first off, you need to generate a key, right? You need to generate key pair. So I think the only thing to note here is that, again, as I mentioned a second ago, we use a single seed phrase to generate two separate keys. We use both MLDSA and SLHDSA. We're going to get to the limitations of what this is a little bit later, but I just want to say at a very high level, the approach here is to try and remain as flexible as possible because we really don't know fundamentally which of these approaches are going to work. Like I said, we have ideas that some of these might work, but for a variety of reasons, either SLHDSA or MLDSA may just not be viable. So in any event, so we let users here generate a key pair, and then you verify your seed. And then this is kind of where, inside this is blurred out because this is someone going through the actual flow here. But here you generate a signature using the new key, two signatures using the new keys that you just generated, and then you sign basically with your Bitcoin key, right? Now that signature, again, as I mentioned a second ago, is done on the enclave. So it's done remote in a trusted execution environment privately. So you're not revealing your public key to anyone. And by the way, I should mention, I don't think I had... Yeah, so I kind of glossed over, so what you just saw is kind of the front end. I glossed over the back end, which is currently, I know, drum roll, very exciting, a database, right? So the current back end is a database. Yes, I know it's disappointing, and we'll talk about how that might change in future iterations of the yellowpages. But bottom line is, the claim sits on a database, and the public key does not sit there for your Bitcoin. Your proof sits there. So the TEE, which is, basically you get this back once you sign your Bitcoin, once you sign in your Bitcoin wallet. I used Electrum there. And this giant bunch of text is basically an attestation from the execution environment that the logic you provided executed correctly, right? So this is a proof, basically, that a signature was valid for a Bitcoin public key without revealing which one. Okay, so that's it. That in its simplest form is the yellowpages. So some technical notes. So yeah, like I said, we use ML-KEM to ensure like a hybrid, hybrid encryption, or hybrid post-quantum security for the connection with the TEE. And again, just to iterate, this is the workflow. I think it missed. There's like a couple things that didn't render, but this is at a very high level the workflow inside the TEE, right? So again, the TEE is really just providing privacy here and ensuring that you're not leaking your public key, right? And then ultimately it is returning an attestation. And it's maybe important to emphasize, and we have a whole blog post, which by the way, on our blog, we have everything that I'm going to present to you is the iceberg tops of what we've written on our blog in terms of technical explanation. But one thing I will say about TEEs and using them is most often in production, TEEs are used blindly, which is to mean they are not, you're just trusting the hardware without the attestation, right? So here you actually have an attestation that's returned, which is, again, the proof that the claim was valid, which is in this case, the signature is valid. Cool. I talked about ML-KEM already. And like I said, in general, in the future, for any server client type work, this is going to be required for basically any kind of crypto infrastructure. Cool. And then we also have created our own address type. Why did we create our own address type and not use something that pre-exists? Well, because nothing really pre-exists yet. And by the way, this is not necessarily implying that the address type that we created will be the standard of the future Bitcoin. But that said, I think it was an interesting exercise, and we learned a lot of interesting things in actually implementing this, right, and applying some of these standards that I've mentioned up here, BEC32M, BIP32, on actually generating these addresses. And by the way, just maybe as like a side note, I think this is mentioned yesterday, but potentially just worth reemphasizing. Signatures for Sphinx certainly are huge, right? And so unless you do something, you have like it's just from like, forget the blockchain bloat, just like from the UI level, gigantic string. We have a blog post where you have like a little side scrolling thing, and you can go for a long time to get to the end of the signature. Public keys for MLDSA are long. They're 10 times longer than a ECDSA public key. So again, for the UX and the readability, from a UX and readability standpoint, ideally you'd like to address those problems. So yeah, that's what we did. And again, we have a whole blog post that covers this if you guys are interested. Okay, future directions. So like I mentioned a second ago, we have a very exciting back-end database Postgres database that currently hosts all the claims. I'm sorry, that's going to be the next slide. So currently we use the TEE. So, TEE has drawbacks, right? On the one hand, it's pretty widely deployed and for many applications is suitable for privacy preservation. But there is an additional assumption of censorship, right? So theoretically, Evervault, who's the provider we use, and they use AWS Nitro enclaves, in case you're wondering. Could go offline. And if they go offline, then you're not going to be able to generate an attestation. So kind of it would be nice to consider a way to be able to generate a proof client side, right? And so I know some people in this room I know have worked previously or are familiar with zero knowledge cryptography, and I think some of that was the topic of Light's presentation earlier. But there's a way, you can use that same approach to generate a proof of a valid signature on the client side. By the way, it's actually, just as a side note, Google Wallet actually has this also rolled out in production for age verification, which is kind of interesting. So this is like getting to be more of a production-ready technology, and I think could be a very good fit for this. And the nice thing about doing that is you no longer have the assumption of liveness for generating the proof, right? For the server, right? What is the trade-off? Speaking as someone who's worked on zero-knowledge cryptography for 5 years, it's complex, right? So there's a lot of implementation complexity. And this is a theme that I'm going to return to at the end of my talk, but I think the question is, for this use case, is it worth it? It's a question we're contemplating. For now, like I said, I think the TEE is a pretty solid starting point. Okay, this is what I was going to say a second ago. The exciting database. Obviously, that's not, we're all here because we're, believe in permissionlessness. Databases aren't really permissionless. So what do we do about that? Well, there's a bunch of things you could do with this, right? So fundamentally, what are we doing here? What is this claim? What are these claims? Like, what does this database look like? It's basically just mapping your old ECDSA addresses or UTXOs to some new address, which is kind of arbitrary because we defined it in this case. But this all it is a mapping, right? What's another mapping? Well, I mean, arguably UTXOs are a form of mapping, right? There's like, public key amount, right? So there's a way where you could actually consider potentially decentralizing this whole thing. So that's kind of the extreme one side. You just could turn this backend somehow into put it on or create a decentralized ledger just for this. Or alternatively, you could hash this database and put a digest on the Bitcoin blockchain and then provide some way for people to verify that, hey, the database that I'm interacting with is actually the one, that is live and that is kind of canonical, right? So there's a whole bunch of ways that you could potentially imagine decreasing the trust assumption, which is currently entirely on Project 11, right? So Project 11 is hosting this database. Its availability depends on us. But there's a bunch of ways that are, I think, relatively straightforward and easy to implement to make this kind of more robust. And I think that's probably a little bit more of an interesting direction initially for us than going down the road of ZK. Cool. The other thing, limitation of this is, and a potential evolution of it, is it would be great to support different address types. Right now, we support pay to public key hash and pay to witness public key hash. What's great about that? Well, 98% of transactions today are of these two types. What's bad about that? Well, as we learned yesterday, there's a bunch of people with exposed public keys, and a bunch of the, $600 million or $600 billion worth of Bitcoin is not under these address types. So it kind of doesn't really do much for a lot of the coins that are actually affected. So it would be nice to be able to expand this potentially into a world where it's supported different address types. Like, for example, and kind of I was in the last bullet, one kind of interesting idea here about this is you can imagine this is what, and hopefully it's obvious by this point, this is an entirely off-chain mechanism, right? So this has nothing to do really with the Bitcoin blockchain necessarily. This is like just on top of it. But one thing you could do theoretically if you're Satoshi, let's say, and we supported P2PK, you could potentially use this to create a heartbeat for yourself, right? So you can effectively have like a heartbeat, which is a claim that is not on chain at all, doesn't reveal anything, right? But it proves that you're alive and there. And maybe you don't want to move anything right away. You're waiting for the evolution of PQ or whatnot. But fundamentally, it provides a way for people who may be exposed to basically say that they actually own the coins without doing anything on chain. And I think the earlier debates today, there's a lot of discussion around how do we know what the line is between who owns something and who's lost something, or who's lost a coin versus who's just not around or is not paying attention. Cool. Yeah, I think this has been covered in depth, but for anyone who's interested, we also maintain a live list of public keys that have been either reused or are just exposed in some way, shape, or form. Someone asked the question the other day, I think maybe it was Peter, I don't know if he's here, but this does not include like the side channels or the multitude of other ways you could reveal a public key, right? So this is, I think as was covered yesterday, this is kind of like the best case scenario in terms of if only these public keys are exposed, like, you know, I don't want to say good, but this is like kind of like the most optimistic case. Obviously, most likely there are other public keys exposed we don't know about. Okay, cool. I'm just running about right on time. So let's finish up here. Okay, changing Bitcoin is going to take years. I think we heard from Clara yesterday her estimates, right? And as I highlighted earlier with my very artistic blocks in layers, my layer cake, there's multiple layers of things that have to migrate. And with each of those things, there are parties and stakeholders that will have opinions, right? And so just like we, in the process of this weekend, or this, the end of this week, have kind of moved forward in forming consensus among our group here, that's all got to happen again and again and again and again at every single layer. So I don't think this is a controversial statement to say that this is going to take years. There's never been an upgraded Bitcoin like this. I don't think we should kid ourselves and pretend like this is guaranteed to succeed, this broad effort to make Bitcoin PQ secure. The challenge is enormous, right? And I think, that's just something that we just have to keep in our minds, right? And what if this upgrade fails, or what if something, what if it forks? What if there are multiple upgrade paths? Like, what do we do, right? So all of these are questions that we don't have answers to because we're just beginning this discussion, right? And so what Yellow Pages is the only production ready and live way today to prove in a post-quantum secure way that you own your Bitcoin, right? That's all it's doing. It doesn't protect you from a post-quantum adversary, but it's letting you generate a cryptographic proof. It's really a social proof that's backed up with a cryptographic proof that you own some Bitcoin at some time. Okay, what does it not do? Well, I already highlighted a little bit that this is not a shield against a quantum computer, right? Really, the motivation of this is providing the minimum viable way, the minimum viable social claim, so as we don't have to all rely on arbitrary claims of ownership after Q Day. Yeah, cool. I think I covered the other stuff. I think the last thing I'll say in terms of caveats, and maybe this is less of a caveat for Yellow Pages, but just more of a general statement, complexity. So I think one thing, so going back, let's see, let me go all the way back here. Okay, so we need to keep in mind, and this is something that I've learned personally from developing Yellow Pages, is we need to keep in mind that complexity only increases up the stack, right? And so I think there are a lot of great ideas that get introduced in the isolation of like a protocol discussion or a Bitcoin mailing list, and these ideas seem like they're going to make things at the low level very simple, but ultimately, potentially, make implementing this very difficult. Let me give like 2 examples quickly. So one is, I think Hunter mentioned a little while ago or yesterday that they had initially considered Falcon as a post-quantum scheme. And why consider Falcon? Well, Falcon actually has the best performance characteristics. Small signatures, relatively fast, small public key size. So why not use Falcon? Well, as he mentioned, this requires every single wallet out there to implement floating point cryptography, which go find any cryptographer that you know and ask them about that, and there's someone shaking their head. Yes, this is like big no-no. You do not want to do this, if you can at all help it, right? So again, this is like a solution at the theoretical protocol level that actually kind of sucks in the real world, which is why I thought, rightfully went away from that, right? But this is true of everything, right? And so yesterday we were kind of discussing, and I think there's a presentation on Sphinx around like, we have different parameters, and maybe we should have like one parameter for certain transactions, another parameter for other transactions. And this is just a reminder that this complexity percolates up all the way through the stack. So theoretically, we can have 10 different parameter sets for Sphinx, for SLHDSA, for MLDSA. All that has to be accounted for at the wallet and infrastructure level, right? And so I think it's very, very easy to lose sight of, as working on the protocol, it's easy to lose sight of the cost and complexity for implementation as it goes up the stack. And for something like this use case, where again, $2.1 trillion is, 1.5 times the GDP of South Korea, right? Like, we have to be holistic when considering the potential security implications of any choice that we make. So, very proud of the work that we've done here, and I think it's sort of inspired some other folks. I know there's like some approaches around commit reveal that I think have been somewhat inspired by this, and happy that we have been able to contribute this. And when I say contribute this, I mean contribute. This is the QR code to our GitHub repository. Everything in here is open source. Everything that I presented is open source. As I said, it is live in production. I think on the first page, the QR code leads to the actual front-end app. And so you can give it a shot, try it yourself. We've had about, I think we're at 1,500 signups so far. And these are the folks, I would be remiss if I didn't acknowledge these guys, folks on my team who helped build this and make this a reality. And hopefully that can include some of you who are interested in potentially contributing. Like I said, these are all open source repositories. Okay, I have 6 minutes left for questions.
Oh, all right. Let's give a round of applause.
Hey, first, thanks so much for actually doing the work on trying to see what these different addresses and signatures look like, actually rendered on a screen and trying to encode them. I think it's easy to forget, like, oh, it's a 14K signature, but like that's horrible. When you were talking about future work, 2 things that we've looked into that might be interesting for you guys. On the signature support thing, if you haven't looked at BIP 322, it's a standard that lets you do signatures for like a Bitcoin address where instead of signing a message, you actually sign a kind of a dummy Bitcoin transaction. And what's great is it works with like all address types. And the Ordinals community has built some tooling to let you like generate and download a PSBT, and then anything that can sign a PSBT will work. So that might just help with like wallet support for you guys if you haven't looked at it. And then the other one is SP1 actually has WASM bindings.
This is the prover there. You're talking about the succinct prover for their ZKVM? Yeah.
Yep. So, okay, cool. If you've already seen it, great. If you guys want to do that client side, you can do it WASM. But great work. Love the project.
Yeah. I think there's a lot of great, interesting primitives for ZK. And honestly, it's incredible just to see. Like I said, I worked in ZK primarily before coming here. And I think 7 years ago, no one thought this was going to be ever practical on a client. Now it really is, which is cool. But yeah, there's still a lot of complexity. So I think it's really just a matter of is the trade-off worth it to invest more in this versus some other thing, like, for example, decentralizing the back end in some way, shape, or form. So, but thank you so much. I appreciate the feedback, and I'll check out BIP 322.
Yeah, on BIP 322, it's been a little unfinished, and I don't think the authors are working on it. So if someone wants to work on a message signing BIP, I think it's looking for a new author. The line to the end. So it is being used. It is the BIP itself is a little incomplete and could use a little more love. It needs basically a push over the finish line.
Oh, cool. Thank you.
Any other questions? Max?
Could you clarify again what the proof consists of other than the attestation, and also whether it would allow proof of a particular, for example, pay to pub key hash?
Yeah, so so the proof is simply, let me go find I think I have it all grayed out, so you're not, oh no, you can see it here. So yeah, so there's the proof. It doesn't really mean anything in this format, but effectively the proof is saying that this is it's signed by the hardware itself, right? So Intel has its, AWS Nitro has its own like signing mechanisms. You're like, hey, this is a valid TEE, and the proof is that the pay to public key hash or pay to witness public key hash signature is valid, right? So the underlying public key you sign and then in order to verify, you need the actual raw public key. The public key hash, of course, doesn't work. So you're basically verifying that signature is valid without revealing it now on the actual claims database, if that makes sense. So if you do that, go for it. You had a question.
Yeah, so the P2PKH hash is included in this proof?
Yeah, so the hash does get included in the claim.
But not the pub key?
Not the pub key, which of course would dox you and expose you to a bunch of potential quantum attacker. Yes. Yeah, Wei.
How are you attacking? How do you know
Great question. I'm very glad you asked that. I'm glad
Can
no one asked.
Can you repeat the question for the live stream?
I will repeat it for everyone. So how are you doing timestamping? Hey, Alex, this is all great, but what if I sign up for this and then send my Bitcoin away in the next block? That's a great question, right? So this currently does not contemplate any kind of like, there's no guarantee around like from that point after the claim that you have the Bitcoin, right? This is a drawback of this approach currently. Now, you can imagine different ways to potentially incorporate this, for example, in existing wallets, where every time you send a transaction, potentially it automatically re-registers you in whatever claims backend. I think that's a really interesting way to apply something like this. But in this standalone example, there really is no guarantee that this is what it's giving you. This proof is a claim at time T, you own these assets, and that is it, right? Now, I think it still works for this worst case scenario that we're imagining, a quantum computer. You know, where's Terry? He left. He's left back working on his quantum computer. Anyway, Terry comes up with a quantum computer tomorrow, and we're all panicking. And I think we can always go back and pick an arbitrary time, and this will be a social consensus exercise again, but there's an arbitrary block height in which we're like, okay, we're pretty sure at this point nobody had a quantum computer, so what are the claims that we know are valid at this time T? And we use this in kind of a social consensus mechanism to kind of recover ourselves, potentially. That's not a very satisfying answer, which is why it was a very good question. But I think that's one of the areas that I think we're kind of looking to apply this is with wallets and basically make this effectively be automated. So you're just always updating your claims to ensure that your assets are up to date. Great question. Light, go for it.
Last question.
Is that the primary way that you imagine this tool being used, is basically as a kind of recovery mechanism if a Q-Day hits sooner than people are able to kind of migrate?
Yes. And the disappointing answer to that question is yes, just because there's a lot. I mean, this is the disadvantage of kind of ignoring all the protocol stuff, right? It's like fundamentally I create a new address type and we have these post-quantum signatures. Like this doesn't move any money, right? So there's kind of like this inherent limitation to it. So really, this is kind of designed to be the minimum viable way where you as a user, as an owner, can retain self-sovereignty in the sense that you can cryptographically show that you own these assets, right? Which is something that goes away in the post-quantum world. So it's really, I think, the intent is to make this as a recovery mechanism. Now, I think there's probably other ways to iterate this and make it something more than that. But at that, it starts to then bleed, obviously, by necessity down into the level of the protocol or some protocol.
Thank you.
Awesome. Great questions, everybody. Thank you.